10th question has sine power 4x. Now how do we handle this sine power 4x? Okay. So sine power 4x, can I separate one sine x and maybe substitute something in terms of cos x? That will create a lot of complications actually if this is not a power which is odd power. Had this been an odd power, I could have written as we did sine cube x, right? We can write one sine x separate and the remaining sine square x can be written in terms of cos square x, and I can substitute cos x equal to t. Here if I take one sine x separate, what I will be left with is sine x, sine cube x. Now sine cube x conversion in terms of cos x will be difficult, and after that substitution will make things complicated, right? So even powers of sine or cosine could be handled by using conversion to multiple angles. Simple idea of conversion to multiple angles. So what do we have? We have sine, the idea is sine square x can be written as actually 2 sine square x, but it can be written as 1 minus cos 2x. And this is the result that we'll use. For converting that, sine power 4x. Oh, but we have written result only for sine square x. Yes, we'll apply this result maybe twice. Yes. So I is equal to sine power 4x dx, this integral. This becomes integral of actually sine square x squared. Sine square x square dx. This sine square x, I'll write it as that. So this is 1 minus cos 2x upon 2 square dx. Yes. This denominator 2 will be squared and it will become a 4, can be taken outside. Integral will have a minus b square, which is a square, minus 2 cos 2x plus cos a square 2x. This is what I'll get. Observe this carefully. This is what I get, right? A square minus 2ab plus b square. That's what you have done. This denominator 2 converts to a 4 and it comes outside. This is easy to integrate. This is easy to integrate, but this still is a bit difficult. So once again, a similar result for cos also exists. That cos square x or cos square theta is 1 plus cos 2 theta by 2. And again, we can use this result over here in the last term. What do we have? This is 1 by 4 integral of 1 minus 2 cos 2x plus cos square theta is 1 plus cos 2 theta, which is 4x whole divided by 2 dx. Now each term is integrable, right? And this is the form in which we can integrate. But one more simplification can be done. Yeah. Therefore, I is equal to, I have a 1 by 2 and I have a 1. Do you observe that? Yes. So these can be added. Yes. So I have 1 by 4 on the outside. Inside the bracket, I'll have integral of 1 will not be difficult. Okay. So integral, can I add this 1 and 1 by 2 first time? Yes, I can do that. Or for the time being, let us keep them separate. Integral of 1 is simply x with respect to x. This is integral of cos 2x. Minus 2 is okay. Cos 2x, the integral will be sin 2x. And you have a 2 in the denominator because of this 2x. Right? Plus you have 1 by 2. This becomes x by 2. Plus you have a 1 by 2 already there. And you want to integrate this cos 4x. The integral of cos 4x will be sin 4x upon 4. And you have a constant of integration. So these are the terms that I'll be getting. 1 by 4 is waiting outside. Okay. X plus x by 2 is 3x by 2 minus of sin 2x. And this is plus 1 by 8 sin 4x within the bracket plus constant. And yes, that is the required integral. That's the final form in which we need the integral. At max, you can multiply this 1 by 4 inside. That is all that will do. This is the 10th question for us.